All right, so one of the first things that I do when I get to lab is I've got these test tubes where I'm going to be collecting fractions for my chromatography column. I'm going to mark them fairly low to the bottom because what I want to do is I want to, actually what I'm doing is I'm using a transfer pipette here, and I'm transferring 1 milliliter into the bottom of this so that I can see what approximately is 1 milliliter. So I'm going to mark my test tube right there to say that's approximately 1 milliliter because I want to collect 1 milliliter fractions, not much more and not much less than that. All right, so the next thing that I want to show y'all is I've got my chromatography column here and I've got it marked off with my high volume level and my low volume level. It's dripping, it's dripping, it's dripping. I'm about to load my protein sample into this. I'm watching my solution, and once it gets to that black line, I'm going to put the cap on the spout so that I can stop the solution from emptying out. Now what I'm going to do is I'm going to get my 1 milliliter fraction. This is one of the tubes that has approximately 8 milliliters of a protein sample that we're going to load onto your column. I'm going to use this transfer pipette, which this transfer pipette has a marking here for 0.5 milliliter, 1 milliliter, 1.5, 2, 2.5, and 3 milliliters. I'm going to bring the solution up to that point right there. Okay, now what I'm going to do ever so carefully is transfer this solution into my chromatography column. Okay, so this transfer pipette right here, I'm done with that. In addition to that, I'm done with my protein sample. As you can see, my protein sample occupies that same space from basically this low line to that high line. The fact that it occupies that range isn't extremely important, but as I continue to add as I begin adding my wash buffer, I don't want my wash buffer going above that. All right, so I have a couple of things in front of me. I've got a transfer pipette. I have my chromatography column suspended in this clamp. I've got kind of an excess of my wash buffer. And then I have test tubes in which I'm going to be collecting fractions. Now, what I'm going to do is I'm going to get my first test tube and set that. Make sure that I can adjust, or make sure that I can actually collect a solution from here. I've got, let's see, do I have everything? Okay, I've got a place to set my test tubes. Got a place where I'm going to get my test tubes from. What I'm going to do is I'm going to find where I put my Sharpie. It's somewhere around here. Here it is. I'm going to label this test tube JWG, indicating my initials, and 1. So there's my labeling system. You can employ your own, but make sure that you'll be able to pick out your sample from the large number of samples that are going to be prepped. What I'm going to do is I'm going to basically let 1 milliliter of a solution flow out of this tube. I've got to, okay, so let's see, just a little bit. Okay, going to take the cap off, collect, collect, collect. The solution is flowing through. You can see the level of my sample is migrating through my column. My sample has a somewhat pinkish hue to it, or a pinkish pigment to it, and there's a milliliter. Okay, fraction number 1, I'm going to set aside. I am now going to collect, and I can see that my resin here is a little bit pink. which is a good thing. So that indicates that my sample is migrating through the column. I'm going to very carefully, very slowly add more of my buffer to my chromatography column, because maybe the most important thing is I do not want to disrupt the bed of my resin. So now what I'm going to do is collect my second fraction. So one milliliter, done. It's another fraction. So now I have 2, okay? The pigment of my sample is migrating through the column, which is just fine and well. My solution is just above my black line. And really, I don't want to add any more of my wash buffer until it's absolutely necessary. So this time it's going to be a little bit funky, because I'm going to begin collecting this fraction, but then also be ready to cap this so I can stop the solution from flowing through. Because what I want is this solution, even though it's above the black line, only a smidge, I'm going to let it flow through, and then I'm going to cap it, and then I'm going to add more buffer. The reason for that is I don't want my protein sample to be in here just constantly being diluted by adding more sample buffer. Because what that means is my protein sample is going to be migrating through the column, and if I overwhelm, or if I fill this column up with additional wash buffer, well then I'm going to dilute the sample as it migrates through. I want it to enter the column as quickly as possible and as in a concentrated way as possible. So here it goes. I'm watching my black line on the column. I only got like 3 or 4 drops in there, but that's fine. Okay, so I'm reusing the same test tube. I'm getting more of my sample buffer, or my wash buffer. I'm adding my wash buffer to my column, bringing it back to that top line, and I'm adding it extremely slowly because I don't want to disrupt that bed. Now, watch as it fills up the test tube. Okay, one thing that I'm observing about these 3 fractions: clear, clear, and you can kind of see it. It's not, all the colors in the background are probably distorting it a little bit, but I can see that these first 2 fractions are a little bit more clear than this one right here, which has a slight yellowish, pinkish tint to it. So my fraction is in there. Okay, now test tube number 4. Again, and what I am doing is I am collecting 5 fractions, then I'm going to read my absorbance at 280 nanometers. I had to do the same thing as I just did. I collected a little bit, and now I'm going to add more wash buffer. I'm adding that wash lysis buffer. That's the sodium phosphate buffer with no NaCl, because what I'm doing is I'm getting the proteins that do not adhere to my column to flow through. Okay, collect, collect, collect. Okay. It's almost done, and I'm kind of watching 2 things. There we go. There is my 4th fraction. Now I'm ready for my 5th fraction. I'm watching my black line there and watching my black line on my test tube. And seen. Okay. Got to add more of that lysis buffer, more of that wash buffer. This is my 5th fraction. And so this fraction is going to be one where I basically put a pause on everything. And now I'm going to read my A280 of these fractions. And scene. Okay, so I have 5 fractions. I'm going to read the absorbance at 280 nanometers of those fractions. All right, so I've got my spectrophotometer. I have 1 UV spectrum cuvette. I've got some deionized water. And I have 2 pipette pins. This pipette pin is my P1000. This has a range of 100 to 1000 microliters. I've adjusted it to 900 microliters. I'm going to get 900 microliters of deionized water added to my cuvette. That is the cuvette that I'm going to use for my blank. And what I'm going to do is I'm going to go do a Lambda assay. I'm reading 1 wavelength. That wavelength is 280 nanometers. That is in the UV spectrum. Not deleting or subtracting any background. I am ready to read my absorbance. I've got the arrow on this one right there. That is going to be pointed and lined up with the arrow that's in the chamber for my cuvette. I'm going to read the blank. Now, I'm going to read sample number 1. Taking 100 microliters of sample number 1. Continue, I blanked it, and I'm going to add 100 microliters to this. Okay, so I wouldn't really expect much to be in here, or much that absorbs at 280 nanometers, because of the fact that this is the very first milliliter that came off my column. So chances are the vast majority of it is buffer. So the buffer that was in my solution. At any rate, I want to collect this data. So my very first sample has an A280 of patience is a virtue, or negative 0.235. Certainly an unexpected number, but I'm going to go with that because I'm recording that. This is the instrument that I'm using. What do I think that means? I think that there's probably something in there that was very diluted. Now that's really kind of strange because I had deionized water as my blank. So what could actually be taken out of deionized water? I'm not quite sure. This is spectrophotometer number 10. So it's and I know that it's entirely possible that this one's simply acting up. But I'm going to take the next few samples, and in the event that it continues to give me sort of weird data, it's pretty simple to read the blank. It's pretty simple to read the sample. So I'll just jump over to another spectrophotometer. I'm back, and now I'm standing. What I'm going to do is jump over to spectrophotometer number 1, which is right behind me. I'm going to do the Lambda assay with this spectrophotometer and check it out, see what I get. So 1 wavelength, 280 is my wavelength that I'm reading. Drag the background now. Read the blank. The blank's not in there. Joel. Oh, that's good. Maybe it's 0.00. Read the blank. Now, collect 100 microliters of this sample. Okay. Read my sample. Spectrophotometer number 1, I get absorbance A280 of 4.000. Okay, so 4.00 is where the spectrophotometer is effectively maxing out. So it's not actually able to read anything that's in there. So now I have 2 very strange data points. I think what I'll do now is jump over to another spectrophotometer. So I decided to not jump over to another spectrophotometer, but rather I'm going to change the blank. Rather than using water, the only thing that the thing that we want to detect is we want to detect protein. So what I did was, now I'm going to try reading my blank, but have my blank be the lysis buffer. So I can read my blank. My rationale is the protein is in that lysis buffer or that wash buffer. And if my blank is simply looking for anything that is, or showing baseline with the lysis buffer or the wash buffer, potentially it can basically detect something that is not in the lysis buffer alone, which would be our protein. So I'm going to try that, hopefully get a better result. So now I'm going to read my sample. This is with spectrophotometer number 10, but with a different blank. So not water, but instead the lysis buffer or the wash buffer. It's the same thing. Wash buffer and lysis buffer are interchangeable. So now I got negative 0.236. Okay. So maybe it's a spectrophotometer. All right. So I've blended all of the spectrophotometers with the wash, the lysis buffer. I'm going to go around to all of them and survey and check what the absorbance is with this sample after blanking it with the wash buffer. I'm optimistic that one or two of them or three of them will give me something to work with. So at any rate, I'm still working on sample number 1, and I'm doing all this so that I can share with y'all, maybe don't use this spectrophotometer because it kind of gave me funky readings, so it's probably going to give you funky readings too. All right, so of our 4 spectrophotometers, numbers 10 and number 9 gave me negative values of negative 0.176, whereas spectrophotometers 1 and 5 gave me values of 4.00. Now, my takeaway from this is I've only looked at one sample, and it's entirely possible that that negative value is a real value. It truly is showing a difference in absorbance. Now, those 4.0 values, I'm not really sure what to make of those. So what I'm going to do is I'm going to read the absorbance at 280 nanometers of these remaining samples. And so I will look at them in all of the 4 spectrophotometers that we have blank, and I will use the same cuvette so that I can limit the number of variables that I have at my disposal or presented to me. So what this will likely mean is that we're going to have to use some combination, or we're going to, for at least the absorbance at 280 nanometers, we're going to be limited on the number of spectrophotometers that we have at our disposal based on what I have after this data set. And what that means with respect to, well, when are you done collecting that sample? Well, one thing that I'm going to take away from this is that spectrophotometers numbers 9 and 10 are giving me a negative value, indicating that I'm going to treat that almost like a 0, basically. So there's no protein present in either of those. Spectrophotometers 1 and 5, I'm not sure what to make of those at this point in time. Like I said, I'm going to look at my other 4 samples and see where that gets me. I could tell from sample number 2 and number 3, number 3 looks like it has more protein in it because of the fact that, well, that sample is basically pink. So I'm going to revisit this in just a moment. Now, what I'm going to do is I'm going to use the same cuvette, which it's entirely possible that the cuvette is the variable or the source of the problem, but I wouldn't think so based on the spectrophotometers giving me different values. Now, what I'm going to do to clean my my cuvette out is I've already rinsed it with water. The last thing that I'm going to do is I'm going to rinse it with 95% ethanol. I filled it up with 95% ethanol, and I'm going to empty that out, and well, that's effectively going to be my drying. I'm going to rinse it a little bit with deionized water before I begin blanking all the cuvettes or blanking all the spectrophotometers again. So between each cycle, I'm going to rinse it thoroughly and blank it again, because I've done something to this cuvette, so I need to blank it to kind of get a fresh start. So I collected all the data from all of these different spectrophotometers. And what I'm going to do is pause for the day. I'm going to revisit this tomorrow what we might end up doing is simultaneously doing our A280 and our A595 so that we can have two measures of presence of protein. See, the tricky thing is that what I'm seeing is for spectrophotometers number 10 and number 9, I got negative values. Those negative values got closer to 0, but they remain negative. Spectrophotometers number 1 and number 5, those going to be 4.0 across the board. So it's entirely possible that they are no longer capable of measuring absorbance for light within the visible or the UV spectrum. So what I'm going to do is I'm going to pause for a moment and then revisit this, where I'm going to measure my A595, so do a Bradford assay with each one of these samples, so that I can have a better idea of whether or not protein is present in those samples. In the meantime, have a good one, and I'll see you later.